Hello everyone, welcome to another video. This time we're going to go through science questions in this video and specifically on this topic heat. So do pay attention because heat is one of those topics that students are weak in. Okay, particularly for the lower block, it's heat and matter. So these are the two topics that students usually will have a lot of problems with. Alright, so we'll look at the things that you're required to know first. Okay, or rather what you need to learn or to understand in this topic. Okay, you are supposed to be able to list some common sources of heat. Alright, it's quite easy. Alright, it's basically anything that generates heat. Most of you know fire. Okay, a light bulb. Okay, what else? Your electrical appliances, most of them will generate heat. Okay, so this one is quite simple and straightforward. If you go through the notes that I've linked in the description, you'll find some of these examples. Alright, and don't forget, if this is useful and you have not subscribed, please do subscribe so that when I upload, you'll get notified. And please do share this channel around with your other friends so that they can learn together with you. Okay, so back to this topic again. State that the temperature of an object is a measurement of its degree of hotness. So basically this is just something that you need to know or remember, because sometimes they will ask, state the difference between temperature and heat. So you will use this particular key phrase. Okay, we call it key phrase. Key phrases are something that you use in a topic. In this topic, there is a specific key phrase. Okay, in fact, a few specific key phrases that you learned. I will go through with them. I will go through with you. Alright, so you need to know that temperature is just the measurement of its degree of hotness. But what does it mean? It means basically, let's say you have a cup of water in that's placed in the room temperature. So the temperature will be around maybe say 28, 29 degrees Celsius. So that's temperature, how hot an object is. So if you have something that just came out of the oven, it could be about 180 degrees Celsius or 200 degrees Celsius. So that's the temperature of the object. It's just how hot something is. That's all. Okay, but heat, on the other hand, heat is an energy. Okay, so if they ask you, if the question asks you, state the difference between heat and energy, this is your answer. The direct answer. Heat is a form of energy, while temperature is a measurement of the degree of hotness of an object. Alright, so again, the second question we've already explained, it just means how hot something is. Alright, you need to understand that heat flows from a hotter to a colder object. Okay, it could be a region, it could be a place, it doesn't have to be an object. Alright, it could be from a hotter area, hotter room to a colder room. Okay, until both reach the same temperature. So this is again some form of key phrase that you might use in a question. Okay, for example, they ask about the temperature of the spoon that's placed in a cup of hot tea or hot coffee, and they ask about the heat transfer. So this is how you might want to answer. Alright, and you'll always mention gain heat or lose heat. Okay, and gain heat. Okay, this is a key phrase. Yeah, I'll just write down a key phrase. Alright, so basically I'm not going through the topic like how I would teach you. I'm just sort of revising, and we will go through more in depth when we are answering the questions. So what's the key phrase? Okay, basically, usually you will say gain heat, and then you must say from. Okay, if you use lose heat, you will say lose heat to. And the third one you would use is conduct heat from somewhere to somewhere. If you basically understand how to use this and you understand the concept, this topic is very, very easy. Okay, so just remember you need to always use these key phrases. Okay, and sometimes you add the effect. Okay, the effect is, okay, or the effects are, okay, these are the effects here. It can, okay, so an example will be, you will say, let's say the spoon gained, okay, the spoon gained heat from the hot tea and expanded. So you added the effect. Okay, and you can also say for the change of state in matter, the water gained heat from the sun and evaporated to form water vapor. So it changed in state of matter. Alright, but you always usually about 90% or more, 99% probably, you'll talk about gain heat from, lose heat to, conduct heat from somewhere to somewhere. And you need to identify good and poor conductors. Good conductors here is already mentioned is metal, and poor conductors, they give some example here. Okay, and you also need to know one more thing. You need to know the type of materials that is used to keep maybe food or water warm longer or hot longer, and the type of materials to keep again food or drinks cold longer. Alright, we'll touch on that, but for now just remember they both, doesn't matter whether you want to keep things hot longer or you want to keep things cold longer. All the time you will use poor conductor. Okay, you will use poor conductors of heat, and I'll explain that when we actually attempt that question. Alright, so again I'll try to keep as best as possible 20 minutes and under. Alright, so probably we'll split this into a few parts. Hopefully not too many parts. Alright, so let's take a look at the first question here. Hashim boiled some water in the pot shown. He is able to hold the pot of boiling water using the plastic handles. This is because plastic is so this is from this part here. Plastic is a poor conductor of heat. Okay, answer is number 3. What does poor conductor of heat mean? It basically means it gains and loses heat. Do not just focus on the gain heat. Okay, so you must also focus on the lose heat part, because then you will have a better understanding of what poor conductors and good conductors mean. So again, poor conductors are objects or materials that gains and loses heat slowly, while good conductor is the opposite. They are the materials that gain and loses heat quickly. Alright, so you must understand is gain and lose heat for both. Alright, some students they just focus on poor conductor or gains heat slowly, and then when they do questions that requires them to talk about losing heat, and then they get confused. Alright, so later on we'll see how we'll apply all this. Next question. Madam Fiza conducted an experiment to find out if water can boil faster in a saucepan with a closed lid. She filled 2 identical saucepans with 1 liter of water and heated them using a similar flame. She observed that the water in saucepan A boiled faster than in saucepan B. So these kind of questions, always look for the change variable, because this is what will, or rather what affected the result. So the reason again here why the water in saucepan A boiled faster is because there's a lid covering. Okay, so we must focus on the lid. The heat from the surrounding air enters saucepan B, causing the water to boil faster. Okay, doesn't make sense because they say here water in saucepan A boiled faster. So when you see this kind of questions, you have to be happy because they basically give you not the answer, but they tell you which one is not the answer. So this again, this is a strategy, eliminating the wrong choices. Question 2. The heat in saucepan A escaped through the bottom of the saucepan, causing it to boil faster. Alright, if the heat escape, we don't say heat escape. Basically, this is totally wrong. Remember, in this topic, the key phrase is gain heat, lose heat, or conduct heat. Okay, we don't talk about escape or whatever other thing. Okay, we just basically focus on those three key phrases. So we strike that out. The heat in saucepan B travel only to the bottom of the saucepan, causing the water to boil slower. Nope. Okay, doesn't make sense also if it travel only to the bottom, because the saucepan will have heat from the bottom. The heat in saucepan A was trapped inside the pot due to the lid. There you go. This is the keyword. Okay, so answer is number 4. So once you know what to look out for, it gets simpler. Alright, the change variable in the beginning of this question, I've already mentioned that the change variable affects the result. So the focus is on the lid. So the answer must have something to do with the lid. Okay, next question. Zachary set up an experiment to find out which material is most suitable to keep Milo warm again. This one I've mentioned just now. This is a very common question. Keeping things warm or cold for the longest period. And what type of material must we use? We always choose poor conductors of heat. It doesn't matter whether we want to keep something warm or cold longer. We always choose poor conductors of heat. So he poured equal volume of Milo at 40 degrees Celsius into 4 identical sized cups made of different materials. He recorded the change in temperature of Milo for 20 minutes in the graph. So you can see a temperature of, okay, we'll always use words from the question. So temperature of Milo in cups, okay, they use the word cup here. Cup A decreased the slowest, while the temperature of Milo in cup D decreased the fastest. Take note, I didn't talk about heat. I didn't mention that the Milo in cup A lost heat to the surrounding faster. I didn't say that because, again, we want to try to be as consistent as possible when we answer a science question, and that is to use words from the question itself. Okay, so that whenever we attempt any question, we are sorry about that. Whenever we attempt any question, we are basically practicing the method, and the more we practice, the better we will get at it. Okay, so which material is the most suitable to keep Milo warm for the longest period? Sorry, I have to cough again. Alright, sorry about that. Having dry throat because I've been talking for almost 30 minutes. Okay, let's carry on. Okay, so we know material A is the best to keep it warm for the longest period of time because the answer is just there. The temperature of Milo in cup A was the highest after 20 minutes. There you go. And if we were to choose, okay, the option is 1. Don't say A. Okay, so if they were to ask which material is best or the most suitable to keep Milo cold for the longest period of time, let's say this time they pour iced Milo, we will still choose A. Again, poor conductors of heat. Alright, so what happened here? Okay, maybe we'll explain this part a bit here. Alright, and we'll end it there. So what happened here is, if you have a poor conductor, okay, so we'll write down here poor conductor of heat. Okay, so it's of heat, it's not poor conductor of electricity. We're talking about heat here. Let's say you have hot Milo here. Okay, the material here will conduct heat. Okay, so that's the key phrase, will conduct heat from the hot Milo, okay, to the surrounding slowly. Alright, so the hot Milo remains hot longer. Now what happens if we have a good conductor? Alright, I'm just going to write good there. It's understood we're talking about good conductors of heat. If I have hot Milo again, so what happened here is the material will conduct heat from the hot Milo to the surrounding faster. So the heat, okay, will be conducted away from the hot Milo to the surrounding faster. So the hot Milo will cool down faster. Alright. Now, what about if, let's say, we put in something cold? Alright, if we put in something cold, okay, let's say ice Milo this time around. Okay, we put something cold. Now, instead of, okay, remember heat travels from a hotter to a colder region or object. So this time round, the hotter area will be from the surrounding, not from inside. So from the surrounding, it tries to go in. Okay, from the surrounding, it tries to go in. Maybe I should use red. Okay, and you can maybe visualize that's the heat. Okay, previously, the heat is from the hot Milo trying to go out. So the poor conductor is not allowing it to go out quickly, because it's not going to conduct the heat away from the hot Milo to the surrounding quickly. While the good conductor, okay, it conducts the heat quickly, so the heat can be conducted from the hot Milo to the surrounding quickly. Now, this time round, the heat is from the outside. So it's trying to go to the cold Milo. But the poor conductor again is preventing it from being conducted to the to the cold Milo quickly. It's preventing that. Okay, because it's a poor conductor, it's not going to conduct it quickly. So what happened is the cold Milo will gain heat slowly. While when if you are using a good conductor to hold the iced Milo or the cold Milo, the good conductor is not going to sort of prevent the heat from the surrounding to be conducted to the cold Milo slowly, but in fact, good conductors conduct heat quickly. So it will conduct heat, it will gain heat from the surrounding, and then it will transfer the heat to the cold Milo quickly. So it will conduct heat from the surrounding to the cold Milo quickly. So the cold Milo will gain heat faster compared to if you use a poor conductor. Okay, so again, no matter whether you want to keep things cold or warm, you use a poor conductor. Alright, so that's it for this video. I hope it's clear. If anything, if it's not clear, if there's anything you want to ask, please do ask in the comment section, so that everybody else who's watching this video, if they have the same question also, they can learn from your question. Alright, and again, don't forget to subscribe if you have not subscribed, and please do share around so that everybody can benefit from these videos. Okay, thank you. See you again in the next one.